Okay, good evening, friends.
Good evening, sir.
Now all of you can see there's a diagram here, right? You can see there's a rigid body here, right? And then there is a reference point O, and then you have got 2 points, 1 and 2, and the velocity vectors are given there. And R1
Yes.
bar, R2 bar is given. So how many variables can you see here? R1 bar, R2 bar, V1 bar, V2 bar. Hello?
Yes, yes,
Yes,
sir.
sir.
Can you relate all of them? Just give me the relation between these 4 variables. Come on, do it. आराम से, प्यार से. Relate all these 4 variables. And you don't need any extra knowledge to relate. No additional concept. Whatever you have learned so far, that knowledge is sufficient. Right? Please, आराम से. I just want you to relate R1 bar, R2 bar, V1 bar and V2 bar. And this is the reference point O. So I want you to relate all these 4 variables. R1 bar, R2 bar, V1 bar and V2 bar. So you must use the property of the rigid body here. One property if you use, then you will be able to relate. There is particle 1 and particle 2. I am giving a hint. Use a very important property of rigid body. Okay, shall I ask all of you one question?
Yes, sir.
What are the properties of rigid bodies?
The particles cannot have relative.
One, cannot have relative velocity. Distance between the particles will remain same.
Angular variables are
Angular variables are same andre adu ಸ್ವಲ್ಪ to be added, not just putting like that.
Yes, sir.
So yes, you are told first 2 properties. The distance between the 2 particles will not change. Correct?
Yes.
Right. So that is sufficient to handle this problem. So exploit that property. Well, we have solved enough problems, numerical problems, interactively. Anybody
1 minute.
close to it? You said the distance between particle 1 and 2 will not change. Exploit that.
So you can replace
Tell.
R1 bar minus R2 bar.
Excellent. So first of all, you say now you create the vector R12 bar. The vector, that is a vector from R1 bar to R2 bar.
Yes.
Okay, so this is R2 bar minus R1, right? Okay,
Yes, sir.
so
Yes.
this will be the vector, correct? So R12 bar. Alright, so having drawn this vector, okay, so the next thing that you can exploit here is that, so now you see you've got a line. You've got a line there.
Yes.
See, then R12 bar represents what? A line.
Yes.
The line
Yes.
from 1 to 2,
Yes.
right?
Yes, sir.
Now you notionally stop particle 1.
Yes. Sir.
So if you notionally start particle 1, then you
Yes,
are
sir.
going to add a vector here to stop, and the same vector you are going to add, right?
Yes, sir.
So what happens here? You are going to end up with
2 bar.
this vector,
Yes, result.
resultant vector.
Yes.
I have
Yes,
drawn,
sir.
I have drawn it this one. Understood?
Yes, sir. That will be V2
So
bar.
anyway, drawing is not appropriate. So here you get this, right? And immediately you know that from the theory that we have learned, R12 bar is one vector, and
Yes.
velocity, that is, what is R12 bar vector? That is this vector. Okay, and V21 bar. What is V21 bar? Velocity of 2 with respect to 1.
Yes, sir.
Yes. Yes, sir.
Okay, correct? Huh? Now, what is the relation between these two? This is velocity of 2 with respect to 1, and this is representing a vector from 1 to 2. What is the relation between these two?
They V by 2. They
Huh?
show V by 2.
Velocity of 1 with respect to 2.
No, velocity.
I want velocity of 2 with respect to 1, man.
Actually, the position vector should be also R21. Yes.
It should be R21, no? Correct.
Yes, sir. R21.
Okay, fine. Then I will take it. Right, thank you. So 1, 2. What is the relation between these two?
So like this V12 bar by R12 bar, sir. Like that will be same, sir. It will not.
Okay, what is the relation between? See, if I give you this and this, there is some relation between the two.
They both are directly proportional.
So, how it is directly proportional?
Sir, omega is V1.
Where is omega given here? See, there is a, see now, hello, anybody? Atal, what is the relation between these two vectors? This is velocity of 1 with respect to 2. This is a radius vector, a vector from 1 to 2. That is, you now have this one, you have got a line, okay, and you have got a velocity vector. Velocity, two particles are rotating. See, this line is rotating. This line is rotating. So if you stop this line, as one of your friends said, is rotating with omega. Okay. Then what will be the velocity? What will be the velocity at this point?
The omega R1 plus.
Okay, this is from here to here, it is R12 bar modulus.
Yes.
From here to here it is R12 modulus, and this is rotating with omega. So what will be the velocity of this? So velocity of this I told V12.
V1.
Yeah.
Omega.
This V12 is perpendicular, no?
Yes, sir.
This is what is the basics, no? Two particles. See if.
Okay, sir, that is what is.
See, listen. If I tell you that this is a line, this is moment notionally at rest or at rest.
Yes, sir.
Okay, and this one is another particle which is in motion.
Yes, sir.
Okay, and if this is omega,
Yes, sir.
then this one, if this line is rotating with omega, then the velocity at this point must be perpendicular, no?
Yes, sir. That
Yes, sir.
So the dot product of these two must be equal to 0.
0, yes.
is. Yes, sir. Yes, sir.
Understood?
Yes, sir.
Understood all of you?
Yes, sir.
Yes, sir.
Okay, so you find out this vector and you notionally stop one and see the other one. This line should be, but this is for the fundamentals of rigid body dynamics.
Yes.
See, that's what you learn. A line is rotating, it's rotating with omega. Okay, and if it is rotating with omega, then that should be perpendicular. Even with the other experiment that we did the other day, ladder experiment. Hello?
Yes, sir. Yes, sir.
Now when this was notionally at rest, so we drew this vector. You remember?
Yes, sir.
Okay.
Yes.
And what is this vector? What is this velocity vector?
E.
It is what is omega into, if the length of the ladder is L, omega into L.
Yes, sir.
Yes, sir.
I hope all of you remember.
Yes, sir.
Okay. Plus to this and this is moving with VA. Okay. We have to add VA to this point. We added VA to this point.
Yes, sir.
And therefore we got the resultant down.
Yes, sir.
And this angle was 90 degrees. That is always the case.
Yes, sir.
Yes, sir.
That is always the case. But the only thing is not the absolute velocity of this particle.
Yes, not
Absolute velocity. It is the velocity of this with respect to this is perpendicular to the line joining the two.
Yes, sir.
And this is undergoing rotational motion.
Yes, sir.
Is it clear?
Yes.
Okay, that is
Yes.
the relation. See, this is wonderful thing. See, this is what I said. See, you have knowledge. You've got to bring out that knowledge in the right form and the right way. Okay, anyways, these are all hard ways to learn. Okay, so this is angular velocity of a rigid body in combination with this. Alright, so I will now start posing some questions to all of you and you should be able to. Oh, Mr. Murthy, be cool.
Therefore,
What is the angle between V21 and R21 bar?
90.
90 degrees.
Thank you. Yes, sir.
Got it? Yes.
Yes, sir.
These are all small issues, but they do matter a lot.
Yes, sir.
All right. So to give you the math model for this, right? This is given here. Okay. So V2 bar minus V2 bar is V21 bar, R2 bar minus R1 bar is so and so. All right. I am not happy with this thing that is written here. So don't see this here. I would rather ask you to see this here. Right? You please see this here. R21 bar is equal to R2 minus R1 bar. So you get here modulus R2 minus R1. Okay. So this becomes R cap 21.
Yes.
Read it as R cap 21. I was not able to type it here. And when you differentiate this, this modulus is fixed because in a rigid body that will not change. And d by dt of R cap 21. Okay, what will happen to d by dt of R cap 21? What will happen to this? So it will give a vector which is tangential to R2.
Yes, sir.
Yes, sir.
It will give a vector which is tangential to R2. I suppose all of you remember. Hey, how? We did not do it or what? dr1 by dr2. The previous one. I sin theta R cap is equal to.
Circular motion.
You forgot? You forgot? Everybody forgot that? Hello? Everybody forgot or only Demon has forgotten? I would like to know. Everybody forgot or only Demon? Everybody have forgotten. Hey, why are you? See, remember this one? Okay, so you should take this one as R1 bar. Huh? If you take this as R1 bar, so you will create a unit vector here, no? R1 cap, remember? And then you created a theta here. Okay, and then this is x-axis and this is y-axis. You remember that?
Yes, sir.
Yes, sir.
Now you created these two because see, d by dt of R1 bar. How will you put it? D by dt of, see, this R1 cap is what? R into R cap. But R is constant because this particle is moving in a circle.
Yes, sir.
So you will get this R out, d by dt of R cap. Right? And R cap now, we are going to represent R cap as what? This is,
I cap plus sin theta.
you will get it as cos theta I cap plus sin theta j cap.
Yes,
Remember that?
Yes,
Yes, sir.
yes, sir.
So
Yes.
d by dt of R cap will be what? Minus sin theta I cap plus cos theta j cap. Right? And if you, so supposing you say this is t cap, okay, and now you say t cap dot r cap. If you take the dot product of these two, you will get 0. Therefore, d by dt of r cap is what? Is perpendicular to r cap.
Okay.
So therefore, you will
Yes.
get the vector like this.
Yes.
Do you remember that?
Yes, sir.
Yes, sir. So, yes, anyway, it's okay, it's okay. Huh? Right. So therefore, therefore, you see here, so R2 cap. So if you differentiate this, you will get a vector V21, V velocity of 2 with respect to 1, right? If you differentiate this, because you are differentiating R to 1 bar. So you will get velocity vector V2 velocity of 2 with respect to 1, and the direction of that will be perpendicular to R1.
R1. R1. R2. Yes.
R2. Okay, so therefore, with that I have written that previous this one. What is that? That is this one. Now, that is how the relative velocity and relative position of. So, what about the orientation of these two? Well, that is one part of the story. The other part of the story is this orientation. Now, again, this is what we proved now here. So R21 dot V21 bar. Well, V21 bar is d by dt of R21 bar. So therefore, it becomes dot product of two vectors, that is simply a scalar quantity, and therefore it is equal to 0. We already proved this. Okay. Now that is the particle 2 is will always move perpendicular to the position with respect to particle 1. Clear? That is particle 1 sees particle 2 moving tangentially in circular motion at any instant of time.
Yes.
Clear?
Yes.
Yes.
The other way to put it is, since particle 2 does not move with respect to particle 1, V1 cos beta 1 is equal to V2 cos beta 2. That is the component of this velocity vector along this line. Okay, so the relative velocity of these two components will be 0. Okay,
Yes.
I have taken beta here, therefore it is. So therefore it is V1 sin beta 2. So thus relative velocity of 2 with respect to this will be this, perpendicular to the line joining the two. And if you take cos of this, then V1 cos beta 1 minus V2 cos beta 2 will be equal to 0. There is no relative motion between the two particles. Already we have discussed. Clear, friends?
Yes.
Huh?
Yes.
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 See, now these are all the fundas of the rigid bodies. So, what is the angular velocity of 2 with respect to 1? So you can have many more questions like this. So finally, you see, in terms of a vector diagram, you can draw it like this. So this is slightly smaller, please excuse me. So this line is v21, that is velocity of 2 with respect to 1, and this is 1. We have notionally stopped at 1. And this angle is 90 degrees. Okay. So that's what. Now relating it to omega. Okay. So displacement. So r21 d theta. That will give you what? A small arc length.
Yes, sir.
And that is equal to v2 into dt. That is also equal to the same arc length.
Yes, sir.
Okay. So when you equate these two, you will get d theta by dt equal to v21 by r21. That is equal to omega 2 with respect to 1. That is omega 2 with respect to 1. We are writing it here because we are using 2:1.
2:1.
Okay. So omega 2:1 is equal to so and so. And you can again write this equation sin beta in terms of sin beta, etc. Okay, and we can get this. This is already written. So you are able to relate it to omega 2.
Yes.
Now omega 21 is equal to omega 12, obviously. Okay, we have done all this by notionally stopping 1 with respect to 2. Now if you notionally stop 2 with respect to 1, you are going to get omega 2. And we know that any line, it is rotating with omega either with respect to this particle or with respect to the other particle. So omega 21 is equal to omega 12.
Yes, sir.
Okay. Well, anyway. So further it is done here. It must be understood that any particle 3 will also turn by the same angle d theta. That is, we have taken 2 particles, 1 and 2. You can experiment it with the third particle. It will also behave the same. Only thing is 3:1 is equal to 2:1. So this is equal to this. Okay. Thus omega ij is same for any 2 particles of rigid bodies. Any 2 particles of the rigid body. We have not taken the particle point outside now. We will go to a reference point outside, and but we have referenced those 2 points. Particles with respect to a reference given outside the body. I suppose we are able to go one step further.